In this video, we're going to look at the factors that influence the speed of sound and how to measure it. We will look at sound waves in more detail in another video. Sound travels at about 340 meters per second in air, at sea level at 20 degrees Celsius. What does this tell us? That temperature and air pressure affect the speed sound can travel through air. And this speed changes again for different mediums. How is this possible? It's all to do with particles. So sound travels at about 340 meters per second in air. In water, it travels at 1,500 meters per second. While in some solids, sound can travel at up to 5,000 meters per second. That's incredibly fast compared to air. These differences are due to how particles are arranged in solids, liquids, and gases. In solids, particles are fixed in rows touching each other. In liquids, particles remain touching each other, but some gaps are present. And in gases, particles are far apart, occasionally colliding with each other. So what's the relationship between distance between the particles and the speed at which sound travels? Pause the video and have a think. The closer the particles lie, the faster sound is able to travel. Sound waves travel faster through solids and liquids because their particles are closer together, so it's easier for the vibration to hit the next particle. Another way of saying this is the more densely the particles are arranged, the faster sound travels. So now we can link this idea to how temperature affects the speed of sound in air. When temperature increases, the kinetic energy of particles also increases. In a gas, the particles collide more often at higher temperatures, passing on the vibrations. So sound will travel faster as the temperature of the gas increases. But what about air pressure? At sea level, the air particles are more densely packed than at altitude. This means at sea level the vibrations of sound pass more quickly between particles and sound travels faster. How does changing the speed of the wave affect the frequency and wavelength of a wave? You should already know how to use the wave equation. If you're unsure, you may want to watch this video first. When the speed of sound changes as it enters a different medium, the frequency remains the same, but the wavelength changes. The frequency cannot change as it is set by the source of the sound. So, as speed increases, wavelength increases. As speed decreases, wavelength also decreases. For example, as sound moves from air to water, it speeds up. Because the particles are closer together in the water than in the air. As the speed of the sound wave increases, so does the wavelength. Can you think of an easy experiment you could do to measure the speed of sound? Pause the video and have a think. One option is to get someone to stand exactly 400 meters away with a stopwatch. Make sure you can clearly see each other. When you are both ready, loudly bang the drum with your drumstick. Your partner starts the clock when they see you hitting the drum and stops it when they hear the sound. Repeat this experiment a number of times, then take the average of all the readings. We can now work out the speed using the equation speed equals distance over time. So speed equals 400 meters divided by 1.2. Giving a speed of 333 meters per second. pretty close to 340 meters per second, but not exactly the same. Why do you think this is? Pause the video and have a think of some possible reasons. Maybe it's colder than 20 degrees Celsius. Or maybe we're at a higher altitude than sea level. Or maybe it's a human error, that the stopwatch timer had slightly delayed reactions. So, we've seen that the speed of sound waves varies between solids, liquids and gases because of how closely or far apart molecules are for the vibrations to pass between. Atmospheric pressure and temperature also affect the speed.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.